Space is vast. It holds countless wonders. Among them is a small moon called Mimas. Orbiting Saturn, Mimas is an icy world. It is not the largest moon, nor the most colorful. But it has something unique. Mimas bears a striking resemblance to the Death Star. Yes, that Death Star from Star Wars. This resemblance is purely coincidental, yet it sparks our curiosity. How did this tiny moon come to resemble a fictional weapon of destruction? What secrets does it hold beneath its icy exterior? This is the story of Mimas, Saturn's mysterious moon. Saturn, the ringed giant, is a planet of majestic beauty. It is surrounded by a swirling ballet of icy particles. These form its iconic rings, but Saturn also has a retinue of moons. These moons vary in size, shape, and composition. Among them is Mimas, a small, unassuming world. Mimas is dwarfed by some of its siblings, like Titan and Enceladus, yet it holds its own in this celestial family. Its surface is heavily cratered, a testament to its long journey through the solar system, but one crater stands out. This crater, named Herschel, is what gives Mimas its Death Star-like appearance. Imagine a giant impact. An asteroid perhaps slams into Mimas. The result? The Herschel crater. This massive crater dominates one side of Mimas. It is about 1/3 the diameter of the Moon itself. The impact that formed Herschel must have been colossal. The crater's rim rises several kilometers above the surrounding plains. At its center, a towering peak juts upwards. This peak is almost as tall as Mount Everest. The Herschel crater is a stark reminder of the violent forces at play in our solar system. It is a celestial bullseye that has captured the imagination of scientists and the public alike. Mimas is more than just a pretty face. Beneath its icy shell lies a fascinating world. Scientists are eager to unlock its secrets. They want to know what Mimas is made of. They want to understand its history, and they want to know if it could harbor any form of life. Space missions like Cassini have provided valuable data about Mimas, but many questions remain unanswered. Is there liquid water beneath its icy surface? What is the composition of its core? The exploration of Mimas is just beginning. It promises to reveal more about the formation of our solar system, the dynamics of planetary rings, and the potential for life beyond Earth. Our story begins not with Mimas, but with its discoverer. William Herschel, a German-born British astronomer, was a celestial detective of the highest order. Born in 1738, Herschel's passion for the cosmos led him to make groundbreaking discoveries. He wasn't just an observer, he built his own telescopes, some of the most powerful of his time. Herschel's dedication to astronomy was relentless. He spent countless nights peering into the depths of space, meticulously charting the stars. His most famous discovery, however, was not a star, but a planet Uranus, the seventh planet from the Sun, found in 1781. This discovery alone would have secured his place in the annals of astronomy, but Herschel's thirst for knowledge was far from quenched. Just a few years after his momentous discovery of Uranus, Herschel's gaze remained fixed on the outer solar system. On September 17, 1789, while observing Saturn, he noticed two faint points of light near the ringed planet. These points of light were not stars. They moved in tandem with Saturn, clearly under its gravitational influence. Herschel, with his keen eye and powerful telescope, had discovered two new moons orbiting Saturn. One of these moons was Mimas, the smaller and fainter of the two. This discovery added to the growing family of celestial objects circling the ringed giant, further solidifying Herschel's reputation as a master of the cosmos. Herschel, following the convention of the time, used Roman numerals to designate his discoveries. Mimas, being closer to Saturn than its simultaneously discovered sibling Enceladus, became known as Saturn was. However, these numerical designations, while practical, lacked the poetic charm that many felt celestial objects deserved. It was John Herschel, William's son and a renowned astronomer in his own right, who proposed that Saturn's moons be given names from Greek mythology. Specifically, he suggested names of Titans, the giant deities who preceded the Olympian gods. Mimas, in this new nomenclature, was named after one of the Gigantes, further cementing its connection to the grandeur and might of the cosmos. Mimas, though small compared to some of Saturn's other moons, is by no means insignificant. It holds its own in a diverse and fascinating family of satellites. Titan, the largest of Saturn's moons, is larger than the planet Mercury and boasts a dense atmosphere and methane lakes. Enceladus, another sibling, spews jets of water ice from its south polar region, hinting at a subsurface ocean. Each of Saturn's moons is unique, offering scientists a glimpse into the diverse processes that shaped our solar system. Mimas, with its ancient surface and Death Star-like crater, provides a window into the violent history of the early solar system, a time of collisions and cataclysmic events. In the centuries following its discovery, Mimas remained a tiny speck of light in the vastness of space, visible only through the most powerful telescopes. Early astronomers could discern little more than its size, its orbital period, and its faint, icy surface. The true nature of this small world, with its dramatic features and potential secrets, remained shrouded in mystery. However, astronomers were patient. They knew that with advancements in technology, they would one day unlock the secrets of Mimas and other distant worlds. The development of space probes and powerful new telescopes promised a future where Mimas would be more than just a point of light. It would become a world to explore, to study, and to understand. Mimas, in the grand scheme of celestial objects, is a relatively small world. It measures a mere 396 kilometers across, making it smaller than Earth's moon. To put that into perspective, if you were to shrink Earth down to the size of a basketball, Mimas would be about the size of a golf ball. Don't let its size fool you. Mimas is no lightweight. Its density suggests that it is composed mostly of water ice, with perhaps a small rocky core. This makes Mimas a fascinating example of a common type of moon in the outer solar system, an icy world shaped by the cold and the constant bombardment of space debris. Section 2. Trapped in Saturn's embrace. Mimas is locked in a perpetual dance around Saturn, its massive parent planet. It completes one orbit every 22 hours and 37 minutes, moving at a brisk pace as it traces a path just beyond the outer edge of Saturn's magnificent rings. This proximity to the rings is no coincidence. Mimas, along with other small moons, plays a crucial role in shaping and maintaining these iconic structures. Like many moons in the solar system, Mimas is tidally locked to its planet. This means that the same side of Mimas always faces Saturn, just as the same side of the Moon always faces Earth. This tidal locking has significant consequences for Mimas's surface conditions, creating distinct temperature differences between its perpetually sunlit and perpetually dark hemispheres. Section 3. Scars of the Past. A surface marked by time. Mimas's surface is a testament to its long and tumultuous history. It is heavily cratered, bearing the scars of countless impacts from asteroids and comets. These craters range in size from small, pinprick-like depressions to vast basins that span hundreds of kilometers. Among these craters, one stands out, dominating the landscape and capturing the imagination: the Herschel crater. This colossal impact feature, named after Mimas's discoverer, is what gives the Moon its uncanny resemblance to the Death Star from Star Wars. Section 4. The Herschel crater. A Cosmic Bullseye. Imagine an impact so powerful that it nearly shattered a moon. That's the story of the Herschel crater. This massive crater, spanning 139 kilometers in diameter, covers nearly 1/3 of Mimas's surface. Its rim rises 5 kilometers above the surrounding plains, and its central peak, towering 6 kilometers high, is nearly as tall as Mount Everest. The impact that created Herschel must have been a cataclysmic event, sending shockwaves through the small moon and leaving behind a permanent reminder of the violent forces at play in our solar system. The crater's size and structure provide scientists with valuable clues about the composition and internal structure of Mimas. Section 5. Beneath the Surface. Unraveling Mimas's Secrets. While the surface of Mimas reveals a world shaped by impacts and the relentless passage of time, what lies beneath its icy shell remains a mystery. Scientists are eager to probe the depths of this small moon, searching for clues about its formation, its composition, and the potential for hidden oceans. Some observations suggest that Mimas might harbor a subsurface ocean hidden beneath its icy crust. This ocean, if it exists, could be heated by tidal forces from Saturn, creating a potentially habitable environment. Further exploration is needed to confirm the presence of this ocean and to investigate its potential for harboring life. Section 1. A Close Encounter. The Cassini Mission. For centuries, Mimas remained a distant enigma, its secrets hidden behind a veil of distance and technological limitations. Early astronomers could only dream of what lay beneath its icy surface, speculating about its composition and the mysteries it held. It wasn't until the dawn of the space age that scientists could finally get a closer look at this intriguing moon. The advent of advanced telescopes and space probes marked a new era in our quest to understand the cosmos. The Cassini-Huygens mission, a joint venture between NASA and the European Space Agency, would prove to be a game-changer in our understanding of Mimas and the Saturnian system. This ambitious mission aimed to explore Saturn and its many moons, providing insights that were previously unimaginable. Launched in 1997, the Cassini spacecraft arrived at Saturn in 2004, beginning its epic journey of exploration. Over the next 13 years, Cassini would travel millions of miles, sending back a treasure trove of data and images that would revolutionize our knowledge of the Saturnian system. Over its 13 years orbiting the ringed giant, Cassini made numerous flybys of Mimas, capturing stunning images and collecting invaluable data. Each flyby brought us closer to understanding the Moon's unique characteristics and its place in the Saturnian system. These close encounters allowed scientists to study Mimas's surface in unprecedented detail, revealing the intricacies of its craters, grooves, and icy plains. The high-resolution images and data collected by Cassini have provided a wealth of information, helping scientists to piece together the Moon's geological history and its potential for harboring life. Section 2. Gravitational Fingerprints, Unlocking Mimas's Interior. Cassini was equipped with more than just cameras. It carried a suite of scientific instruments designed to probe the depths of celestial objects, revealing their hidden secrets. One such instrument was the radio science subsystem, which used subtle variations in Cassini's radio signals to measure the gravitational pull of celestial bodies. By carefully analyzing these gravitational fingerprints, scientists could infer information about Mimas's internal structure. The data suggested that Mimas is not a uniform ball of ice. Instead, it likely has a denser core, probably composed of rock, surrounded by a thick mantle of water ice. This finding provided crucial insights into the Moon's formation and evolution. Cassini's observations of Mimas yielded more than just information about its interior. Scientists noticed something peculiar in the Moon's rotation. Mimas wobbled slightly as it orbited Saturn, a telltale sign of an uneven distribution of mass within the Moon. This wobble, known as a libration, was more pronounced than expected for a solid body. This unexpected wobble, combined with other data, led some scientists to propose a startling possibility. Mimas might harbor a hidden ocean beneath its icy shell. The gravitational tug-of-war between Saturn and the larger moon Enceladus could generate enough heat within Mimas to keep this ocean in a liquid state. The presence of such an ocean would have profound implications for the search for life beyond Earth. Mimas's story is inextricably intertwined with that of Saturn's magnificent rings. The Moon's gravity, though weak, exerts a powerful influence on the countless particles that make up the rings. Mimas acts as a shepherd, herding ring particles into specific orbits and creating gaps and resonances within the ring system. The most prominent example of Mimas's gravitational influence is the Cassini division, a 4,800-kilometer wide gap between Saturn's A and B rings. This gap is not empty. It contains fainter ringlets and is sculpted by the gravitational resonance with Mimas. For every orbit Mimas completes, particles in the Cassini division complete 2 orbits, creating a gravitational tug that clears out the gap. Despite the wealth of information gleaned from Cassini and other missions, Mimas remains a moon of mystery. The possibility of a subsurface ocean is tantalizing, but its existence is far from confirmed. Further exploration is needed to determine whether this icy world could harbor the conditions necessary for life. The origin of Mimas's wobble is also a subject of debate. While a subsurface ocean is one explanation, other possibilities, such as an irregularly shaped core or variations in the thickness of its icy shell, cannot be ruled out. Mimas, with its enigmatic features and tantalizing hints of hidden secrets, beckons us to return, to explore further, and to unravel the remaining mysteries of this fascinating moon. Mimas, with its heavily cratered surface, stands as a remarkable witness to the history of our solar system. Its ancient ice, preserved for billions of years, serves as a time capsule from the early solar system, offering a glimpse into the past. The surface of Mimas bears the scars of countless impacts over billions of years, each crater a testament to the chaotic and violent conditions that prevailed during the formation of planets and moons. By meticulously studying the size, distribution, and composition of these craters, scientists can piece together a detailed timeline of events that shaped the solar system we see today, unraveling the mysteries of its early days. The Herschel crater, in particular, stands out due to its massive size and depth, providing valuable insights into the forces that shaped the early solar system. Its massive size and the energy involved in its formation suggest a time when collisions between planetary building blocks were common, reshaping the landscape. The study of such impact craters helps scientists understand the processes that led to the formation of planets and their moons, including our own Earth and its moon. By examining these ancient scars, we gain a deeper understanding of the dynamic and ever-changing nature of our solar system. Section 2. Planetary Formation, Piecing Together the Puzzle. The formation of planets is a complex and chaotic process. It begins with a swirling disk of gas and dust surrounding a young star. Over time, particles in this disk collide and stick together, gradually growing larger. These larger bodies, called planetesimals, continue to accrete material, eventually forming protoplanets. Mimas, like other moons in the outer solar system, likely formed from the leftover material that swirled around the nascent Saturn. As Saturn grew in size, its gravity drew in gas and dust, forming a circumplanetary disk. Within this disk, particles collided and accreted, eventually giving rise to Mimas and its sibling moons. Section 3. The Dance of Moons and Rings, a Delicate Balance. Mimas is not just a passive observer in the Saturnian system. Its gravity, though weak, plays a crucial role in shaping and maintaining Saturn's magnificent rings. The moon's gravitational influence creates gaps and resonances within the rings, sculpting them into the intricate patterns we observe today. The Cassini division, the most prominent gap in Saturn's rings, is a testament to Mimas's gravitational influence. The moon's orbital resonance with particles in this region clears out a path, preventing the formation of a continuous ring. This delicate dance between moons and rings highlights the interconnectedness of celestial objects and the subtle ways in which gravity shapes the cosmos. Section 4. Mimas, a stepping stone to the outer solar system. Mimas, with its icy composition and proximity to Saturn, represents a class of celestial objects that are common in the outer solar system. These icy moons, often found orbiting gas giants, are thought to hold clues to the formation and evolution of planetary systems beyond our own. The study of Mimas and its counterparts provides scientists with a broader perspective on the diversity of worlds that exist in our galaxy. By understanding the processes that shaped these icy moons, we gain insights into the potential for habitability beyond Earth and the possibility of life as we know it existing elsewhere in the cosmos. Section 1. Mimas, a sentinel of the cosmos. Mimas, a seemingly insignificant moon orbiting a giant ringed planet, has revealed itself to be a captivating world. This small, icy body, often overshadowed by its larger neighbors, holds a unique place in our solar system. Its Death Star-like appearance, a cosmic coincidence, sparked our curiosity, leading us on a journey of discovery. The massive Herschel crater, which gives Mimas its distinctive look, is a testament to the moon's tumultuous history. From its discovery by William Herschel in 1789 to the close scrutiny of the Cassini spacecraft in the 21st century, Mimas has slowly unveiled its secrets. Each mission has brought us closer to understanding this enigmatic moon. We've learned about its violent past, evidenced by the massive Herschel crater, which is nearly a third of the moon's diameter. This colossal impact event has shaped Mimas's surface and its history, and the possibility of a hidden ocean beneath its icy shell. This tantalizing hint of a subsurface ocean suggests that Mimas might have more in common with other ocean worlds like Europa and Enceladus than we previously thought. Mimas is more than just a celestial oddity. It is a key to understanding the formation of our solar system, offering clues about the processes that shape the planets and moons around us. The intricate dance between moons and rings, and the gravitational interactions that govern their movements. These dynamics are crucial for understanding the stability and evolution of planetary systems, and the potential for diverse worlds beyond our own. Each moon, Each planet tells a part of the story of our cosmic neighborhood, and Mimas is no exception. As we continue to explore the cosmos, Mimas stands as a sentinel, a guardian of ancient secrets, and a beacon for future discoveries. A reminder that even the smallest of worlds can hold profound secrets, waiting to be unlocked by our insatiable thirst for knowledge. Each new finding on Mimas adds a piece to the puzzle of our solar system's history. As we look to the stars, Mimas remains a symbol of the endless possibilities that lie in the vast expanse of space, urging us to keep exploring and discovering.